What's inside this black box? You guessed it, a power supply. But what exactly is it and how does it work? Well, it's a bit more than meets the eye. Let's open this bad boy up and take a look at some of its internal components. This chunky metal thing right here is actually a transformer. This little copper coil wrapped around this iron core is going to be our first key component. So what does it do? Well, it will either increase or decrease the alternating voltage supplied to the power supply. And no, it's not magic. It's science, specifically physics. And speaking of magical powers, if you don't already have an account, now is the time to get one. Now let's get back to the magic. When we connect the primary winding of the transformer to an input voltage, an electrical and magnetic field starts to build up. This change in the magnetic field through the iron core induces a voltage in the secondary winding. This phenomenon is known as electromagnetic induction. By adjusting the number of turns of wire in each winding, we can control the ratio between the input and output voltages. If the secondary winding has fewer turns than the primary winding, then the output voltage will be lower than the input voltage. Likewise, if the secondary winding has more turns, then the output voltage will be higher. Let's say we want to use a computer power supply to power a laptop. Laptops typically operate on a voltage range of 12 volts, while computer power supplies produce 120 or 230 volts from the wall. We cannot connect the laptop directly to the power supply because it would burn up. Therefore, we need to step down the voltage to a suitable level. In this case, we would use a transformer with a higher number of turns in the primary winding and a lower number of turns in the secondary winding. This will result in a lower output voltage that can safely power our laptop. Now that we've stepped the voltage down, we need to convert the alternating current to direct current. Why do we need to do this? Well, the computer chip inside the laptop requires the current to flow in only one direction. And as you can see, the waveform of alternating current changes direction periodically. To solve this problem, we will insert a component called a rectifier. A simple rectifier circuit uses 4 diodes arranged in a bridge configuration. Here's how it works. When the input voltage is positive, the first 2 diodes conduct current, allowing it to pass through the circuit. When the input voltage becomes negative, the second 2 diodes conduct, again allowing the current to flow. This process effectively converts the alternating current to pulsating direct current. However, the output is not entirely smooth, as it still contains ripples. To address this issue, we add a filter to the rectifier. Typically, this is done by adding large value capacitors across the output. These capacitors store electrical charge when the voltage is high and discharge when the voltage is low. This helps to smooth out the ripples in the output voltage, resulting in a more stable DC signal. We're almost there, folks. We now have a pulsating DC voltage that flows in the right direction, but it's not yet suitable for powering sensitive electronic components, such as microchips. You see, the voltage needs to be constant, and any fluctuation could damage the components. This is where our last key component comes in, the regulator. A regulator essentially keeps the output voltage constant, despite any fluctuation in the input voltage or load. There are 2 main types of regulators, linear and switching regulators. We'll discuss both, but first, let's look at a common linear regulator, like the 7805. This guy takes an input voltage, ranging from 10 to 35 volts, and outputs a nice stable 5 volts. How does it do this? Well, the secret lies within this little chip. Inside it has an internal reference voltage, which compares the input voltage to the desired output voltage. If the input voltage is higher than the output voltage, then the regulator allows current to flow in a feedback loop. effectively lowering the input voltage until they match. This means that the voltage drops across the device equals the difference between the input and output voltage. As the load increases, the output voltage drops. The regulator detects this drop and raises the output voltage back up to the desired level. Now, why do we use linear regulators? Well, they're relatively simple, easy to use, and provide a very stable output voltage. However, they have a few drawbacks. First, they are less efficient compared to switching regulators due to power loss in the pass transistor. Second, they tend to be bulkier and more expensive. Switching regulators, on the other hand, are more efficient and smaller, but can be more complex. They work by rapidly switching the input voltage on and off at a high frequency, thus controlling the average output voltage. For example, a buck converter steps down the input voltage, while a boost converter steps it up. We won't go into too much detail here, as they're pretty complicated. Just know that they work by switching the input voltage on and off at a high frequency. Okay, so now that we have a regulated DC voltage, we can connect our laptop charger, smartphone, or any other gadget that requires a DC power supply. But wait, don't unplug just yet. There's one more thing I want to show you. Have you ever noticed that your computer shuts down when there's a power cut? Well, that's thanks to this guy, the uninterruptible power supply, also known as UPS. It contains a battery that takes over when the power goes out, ensuring that your devices can shut down properly. Some UPS also have surge protectors built in for added safety. That's all for now. We hope you enjoyed learning about the power supply and how it converts and regulates electrical power. Remember to subscribe for more videos and leave a comment below if you have any questions. Thanks for watching.